Section 2-6, Quadratic Models Part 2. I need you to get your graphing calculator out. Make sure it's turned on. That would be helpful. I won't name any names. We are going to write a program that's going to be useful to you. So right about in the middle here it says PRGM for program. We're going to press that program button and you're going to see execute, edit, and new. We are going to go over to where it says new. You'll also see a title come up that says create new. And we're going to type enter, hit enter. It will ask us, right now it's asking us to name the program. I see that the alpha lock is on. So all of the green letters on my screen, on my calculator, are active. And I'm going to call it quad form. So excuse me, this is not like a QWERTY keyboard. Q U A D. Google can't spell. Yeah, not QPad. That would be awkward. Q U. There we go. And then I want an F, an O, an R, and an M. Quad form. So that's what we're going to call it. And it's basically the quadratic formula. Now, we would like it to ask us for letters A, B, and C, which are the coefficients of the squared term, the linear term, and the constant term. So we're going to hit the program button again, but this time you'll notice it gives you a whole bunch of menus that it didn't give you before because we're in the middle of a program. These are where all the programming instructions are. Well, we're going to go over to where it says input output, I/O, and we're going to go to the one that says prompt. And we want it to prompt letter A. So I'm going to use the green alpha lock button, green, and then I'm going to hit the A. So by using that one time, it allows me to activate one letter. Okay? If you use the yellow button, then the green button, it actually will lock in all the letters, and then every time you touch something, it's going to be a letter and not what you might have expected it to be. Okay? Well, then I'm going to come down to the next line, and I'm going to hit that program button again, and go back to the input output and the prompt. Okay? And I'm going to call it alpha B. All right? Have to use the green alpha button once, and then find B. All right? So I'm going to do it one more time for C. Program, input output, prompt, alpha C. Okay, so now what it's going to do when we actually run this program is it's going to ask me for A, and then I'm going to tell it a value in B and C. It will store that number in those memory locations A, B, and C. So now we are going to actually calculate something. We're going to calculate one part of the quadratic formula. So I'm going to use parentheses. The opposite of B plus, we'll do the minus part next, the square root of B squared minus 4 times A times C. Now remember, every time you want to activate one of those letters, you have to use the alpha button right before you change it. So like you'd have to use the alpha A and then the alpha C in order to get the A and the C to appear on screen. Okay? So that's negative B plus the square root of B squared minus 4AC. Okay, so I'm going to use my other parenthesis. Divided by 2 alpha A. Now just for fun, I'm going to put another set of parentheses in here. So the whole thing is in parentheses, just like this. And if you wonder how I put it in there, remember I used the INS feature, the insert feature. So when I went up there to put that other parenthesis in there a few seconds ago, I used the insert feature, and then I was able to hit the parenthesis. So I didn't have to retype everything. Okay? So now, right above the on button is the stow button. I think that stands for store. So we're going to stow it in a location. Which location do we want to stow it in? We're going to stow it in letter D. So I use the alpha and then the D. And so Now, I'm going to go through this process again, parenthesis, opposite of b. Now, please make sure that you are using the little negative at the bottom of the screen for this. Okay, but when you use the minus 4ac, use that one. Okay, you'll notice that they're actually, one's a little bit shorter than the other one. This time I'm subtracting, right, because I'm doing the other half of the quadratic formula. B squared minus 4 alpha A alpha C, parenthesis, parenthesis, divided by parenthesis 2 alpha A, double in parenthesis, stow in letter E. Okay, so I'm storing half the quadratic formula in D and the other half in E. Okay, and so now all I really needed to do is to actually display D and E. Okay, so that's what I'm going to do here. I'm going to say go back to the program button and the input output, but this time I'm going to push DISP for display, and I want it to display D. And then right after, I'm going to do the exact same thing. Program, input output, display, alpha E. And really that's all you have to do is that's the end of the program. You don't have to do anything more to it. It will spit out D and E, which are the values of the quadratic formula. So for instance, in your textbook, just to test this out and make sure we didn't screw anything up, in example 1 in your textbook it says here's a quadratic equation, find its x-intercepts. We all know that the quadratic formula is used to find x-intercepts. So we're going to quit, jump back to the home screen. Ironically, I had that equation in there. Wow. Okay, so 2x squared, so 2, negative 3, negative 2. So on the home screen, I'm going to hit program, but this time we want to execute the file. All right, that doesn't mean we're going to hurt it. That means we're going to make it run. Okay, this slide. Make sure nobody got confused. It automatically asks me for A. So, 2. It asks me for B. Wasn't it negative 3? Yep. Negative 3. Don't use a minus sign. Use the little negative. And then negative 2. Now, according to the answer sheet, we should get 2 or negative 1/2, right? 2 or negative 1/2. Okay, those are the two possible x-intercepts. And just to check, yes, we got it. Okay, it tells us that it's done with the program, so therefore I know that it's got the answers and it's not continually working on something. Okay, so there you have it. It spits out the values, and it might come in handy for you. Okay, now back to the rest of the video here. So the rest of it that I didn't want to get into the last time because I thought the video would be too long involves finding a quadratic model given 3 points. Now, we did this in an even more drawn out, dramatic way last year, so you'll at least be assured that you don't have to abuse yourself with a lot of elimination. Okay, that's not what we're going to get at. We're going to use matrices, which is much easier, especially with a graphing calculator. All right, so I need 3 equations. It doesn't matter which one you start with, so we'll take this coordinate right here. There, I've been given 3 points, and I'm looking for a quadratic model that goes through these 3 points. So I'm really trying to figure out A, B, and C. Well, so these are x values and y values. All right, so 340 is the y value. I've got A times 1 squared plus B times 1 plus C. And then I'll put it in the next equation, 320 equals A times 2 squared plus B times 2 plus C. And then we'll give myself 290 equals A times 3 squared plus B times 3 plus C. Notice that the A is not squared. Children, don't listen to me ever on that one, and they ignore that, and then they screw the whole problem up. So don't be the one that writes A squared, because that's not true. Only the x is squared on the first term, and we already have a value for it in each one of these equations. So now I'm going to rewrite this, okay? Hopefully this makes sense. I'm going to rewrite the first equation. 1 squared times a is just a, and then 1 times b is just b, and then c. And I'm going to put equals 340. Okay, hopefully it doesn't screw you up that I put the 340 on the other side. And then 2 squared is 4, so that makes 4 a's, and then 2 b's, and 1 c equals 320. And then 3 squared is 9, so that makes 9 a's, and 3 b's, and 1 c equals 290. Last year we would subtract the equations and get rid of the c, and then eliminate and continue to eliminate until we got down to the value of a, and then we would work our way back, substituting until we got b and c. Okay? Long drawn out process. We're going to use what we know about matrices, right? Now I'm going to pull off the coefficients. 1, 1, 1, 4, 2, 1, 9, 3, 1. We know that that's being multiplied times a, b, c, and we're getting 340, 320, and 290. Okay? We talked about last year how we had a times x equals b. Now the only way you are going to get rid of this coefficient, don't you dare tell me that you're going to divide both sides by a, because there is no matrix division. We talked last year about how you would take the inverse of the coefficient matrix, and we would left multiply by that. And this turned into the handy-dandy identity matrix, and we know the identity matrix times any other matrix is that matrix itself. Okay, just to refresh your memory, that was the whole 1, 0, 0, 1. It would be a little bit larger in this case because it's a 3 by 3. It actually would be more like 1, 1, 1, 0, zeros all over the place. Right, because it'd be a 3 by 3 identity matrix. But the point still exists that the identity times any other matrix is that same matrix. That's why we call it the identity matrix, because it doesn't change the matrices or the matrix identity, if that makes any sense. Now you're saying, okay, well that's all well and good. For all intents and purposes, folks, when you multiplied by a inverse on the left side, boom, it disappeared. And what you really wanted to happen was on the other side. Now, I hope you understand that a inverse cannot be on the other side. That is not possible. We talked about our rules for when you can and when you can't. So if you're going to do this the wrong way, you're going to get the incorrect values. So the coefficient matrix we're calling A, and the constant matrix we're calling B. Right? This one was called, so this was coefficient, and we had variable and constant. And hopefully this is Celine Dion moment. It's all coming back to you now, or sometime soon. But it's pretty easy to do with the graphing calculator. Good thing we didn't show you this last year. Okay, so, or do a lot with it last year, because, you know, you would have gotten all the questions right. Okay, so we're going to jump into the matrix section. Now, on my calculator, the matrix section is down here on the left side. So I hit that button. Okay, I'm going to go over to edit. We're going to edit matrix A, and it's a 3 by 3 matrix. And the numbers I had on matrix A were 1, 1, 1, and 4, 2, 1, and 9, 3, 1. Now, some of you might say, well, what if I rearrange the equations? Would it be okay? Sure, as long as all of the values are the same. Like if you put the 1, 1, 1 at the bottom and had 340 at the bottom, that's still okay. It's still going to work out fine. Okay? As long as you rearrange them correctly, it will not be a problem. Okay, so I'm going back to the matrix edit section for matrix B. And matrix B, this constant matrix over here, is a 3 by 1. 3 rows and 1 column. It's easy to tell that's a 3 by 3, but this is a 3 row by 1 column. For those of you who don't remember, it's downright easy to tell. Down is the rows, over is the columns. 3, 1. Right? 3 rows, 1 column. Okay, and those values were 340, 320, 290. Okay, so now back on the home screen, so I quit and I get back on the home screen, and since I know it's easy to solve this by using A inverse B, I'm going to go back to the matrix section, but this time instead of going over to edit, I'm going to stay in the names category. I'm already highlighting A, so I'm going to hit the enter button, which puts A on the home screen. Now, right back where that matrix button was is the X inverse button, so I'm going to hit the inverse. All right, so that's A inverse. Now I go back to the matrix section under names and I choose B. A inverse B. And when I hit the enter button, look, it gives me A, B, and C. -5, -5, and 350. -5, -5, and 350. So, knowing that information, -5, -5, and 350, I can then write my equation. Y equals -5x squared minus 5x plus 350. Plus, trust me, once you get good at this, it'll go fast. It's not that big of a deal. Okay? And there's another way to do this, which you can use to check your work, but you need to be able to you can use your lists, okay? And so you could go in here and use lists. So we had 1, 340. Oops, sorry. 1, 2, and 3. Those are my x values, and 340, 320, and 290. Okay. We remember that under stat calculate there is the linear regression. But there's also quadratic regression. And so if we use that on list 1 and list 2, we can come up with those values as well. I know you're saying that's the easy way, but you need to know that there are multiple ways of handling situations. And so we're going to make you use matrices as well. Now, you're going to have to use this quad reg in a variety of situations. Like, for instance, I'm going to use the data in at the bottom of page 124 with the veterinarian who's collecting a bunch of information on pig feed and percent weight gain. So I'm going to go into my lists, clear things out, and we had 0, 1 through 7, 2, 3, 4, 5, 6, and 7. So I got those values entered in my calculator. And then 10, 13, 21, 24, 22, 20, 16, and 13. Okay? And so we can make a scatter plot of this. We know how to make a scatter plot. We can make sure we turn it to on. And we're going to use zoom 9, right? Because zoom 9 gives us the best looking picture. Now, that data definitely does not look linear. It does not look like a perfect parabola, that's for sure. But we can use quad reg to find that particular. We can do it the more difficult way with the matrices, which isn't really that difficult. Pick 3 points, make 3 equations, throw it into the matrix. But we're also going to need to be familiar with quadratic regression. List 1, comma, list 2, just like we do on exponential regression and linear regression. And so now we're going to find those values. So I'm going to write those numbers down here using, so y equals -0.97. It rounds to the thousandths rounds to 0.970. I don't really need the 0 in there, but I'm just trying to be consistent so you can see 7.161x plus 9.292. Okay, so I can go to the y equals, write down this equation, -0.97x squared plus 7.161 x plus 9.292. Okay, so enter your equation in. Don't forget you've got an x squared term and an x term. Okay, if you forget one of the variables, that will be critical and you'll be like all confused. Alright, so here's my equation of my parabola that's on my data. Okay, you can tell it's not perfect, but that is the model that goes with this particular set of data. There's no theory that goes behind this. For instance, if you would go back to the example with the gravity formula, it's a perfect parabola because there's a theory behind it. This is not a theory. In fact, sometimes they use the term impressionistic models or non-theory based models. So, in other words, we think this is a parabola. We're not sure, but that's the best guess that we have. Or maybe this is just what we are anticipating would be a good model for it. And as we're going to see in a little bit, we're going to be able to prove one way or another whether the model is exponential, linear, quadratic, and we're going to have some reasonable backing as to why. And we'll talk more about things in class.